redo it. I don't think so.
Extra practice.
You have enough space on your drive this time.
I got enough space.
Actually, we'll see it if you just once you minimize it, let's have a brief screenshot.
Actually, what I should have done is to turn on logging, so that way you can actually just look at the times of the entry, and then you can see exactly what's going on. But you won't be able to hear the explanation. It's okay. How are you guys going to take classes after this, when no one else is going to record their lectures? They do?
Yep.
They're starting to? Well, that's good. I actually taught a class, a workshop on campus for other professors, and the whole topic was how to do screen recording in a classroom using only open source and free software. And there were a few people here, and I think we ended up with a few converts. But very few or no one wanted to switch to Linux yet. So I'm still the only one doing it in Linux.
Running on flash drives. It's running on flash drives. You should just pass out flash drives everywhere.
There you go.
Yeah, I don't think that's the issue. I don't think that was the issue. All right. So now we can move on to the next homework assignment, which is more important. The next homework assignment is sub2. I just didn't feel very inventive, so just called it sub2. And it's due next week. You have 1 week to work on this. And then after that, we'll have our practice exam and then also our exam number 2.
After Thanksgiving? Is that after Thanksgiving?
I have to look at the schedule to find out what it is. Okay, now this one.
It's not that bad.
It's not. I know what you guys are thinking. It's like, oh man, that's horrible. But if you just look at the actual number of lines that actually do anything, it's not that much, right? I mean, the by val by x, that doesn't do anything.
Yeah.
So for the most part, the program only has this bunch of stuff.
Yeah, it's easy.
It's not that bad. Okay? Well, but it does involve a new concept that we are going to talk about today. Now, most of this stuff you already know. Passing by reference, like this one here, not a problem. We talked about it. Passing by value, we talked about it. Passing, things along using, the invoke statement, we talked about it. What we haven't talked about yet is the concept of returning. Okay, what does that mean, and how do we do something like this crazy stuff here? Okay, putting an invoke entirely on the right-hand side of an assignment statement, or putting it. Ooh, you know what? I made a mistake here. I just caught myself. Okay, this has to be going to Y, so I have to resave the file and upload it again. Okay, so I just caught myself because I have an entire invoke as a source of information to go into a parameter. Okay, so we will talk about all this stuff, and it has something to do with what we talked about the other day. Remember, I talked about prefix, infix, and suffix notation. How you can put an expression as a part of another expression. You remember that? Well, we are going to do it here. In other words, we can utilize the result of one subroutine invocation to provide the result or the value for something else to start to execute. Okay. So first thing first, let me re-upload this file before I forget. So we have to go to here, edit settings. Go to the document, go to the link.
Yeah, I noticed that. That's the first time I noticed that screen this moment. You could change like the license agreement.
Yep. But it's becoming more of a big thing these days, than before. And I put it into download, I think. It's called sub2. And I better close the file first.
As long as we don't have to do an NDA for the class.
close it first. I'll reopen it later. And then open it, upload. It will complain that I have a file of that name already and ask me whether I want to overwrite it. Overwrite. And update. That should do it. All right. So that's good. Okay, now we can go back to the same document. Okay, you guys have any questions? All right. So let's just focus for now. Every time I say focus, the image of Po the panda just pops up in my mind. Po from Kung Fu Panda. Because there was one scene, because Po was not very focused, right? He just keeps going on and on. Who was the voice actor of Po the Panda? Jack Black. You can probably imagine why he has problems focusing. So there was one scene when Shifu which is the panda thing Dustin Hoffman, right, and say focus Po, focus. That was funny. So whenever I say focus, either with my kids or anybody else, the image of Po the panda not paying attention just kind of pops up in my mind. All right, so let's see. Okay, the homework assignment is done, and now we can move on to the first sample program with the concept of returning a value. Okay, so we'll go ahead and make it as simple as possible. So we'll define a subroutine. We'll call in the class notes, in the notes on the website, I use 7. So in here, I'll just pick something else, like lucky number. So this is the name of the subroutine, and all it's going to do is to return a specific thing, a specific number. We'll call it 13 here. All right. And then outside of the subroutine, we have a global variable, or better yet, I just have a print statement. So I don't even have any global variables, any variables whatsoever. And what I'll print is the result of the invocation of lucky number. Lucky number. All right. Yes, I know 13 is not a lucky number. That was a joke. Some people will say, but I'm not going to download this file. It's unlucky because it has 13 in it.
Well, isn't that the case with everything?
Well, the homework did.
Always a row 13?
Yeah, always a
The homework did, yeah.
yeah.
Some buildings in Hong Kong actually does not have a 13th floor. They skip that floor. Oh, really? They skip the floor?
There's still a
either
13th
12
floor, though.
And then 12B, or they'll just go to 14.
Oh, wow.
Literally, there's a 13th floor.
There's literally, but they just won't name it.
It's 12A, 12B, 14.
Ridiculous.
That's good setting for horror movies, right? There's no
It's been
13. It's been done many, many times.
Microsoft Office also skipped in their numbering system, their internal naming scheme. They went from 12 to 14 instead of.
That is kind of funny. As a technical company, right? Technology company. Well, they can say instead of 13, they can say 1101 instead. In binary, right? 1101. Or better yet, D. It's floor D. It's not the 13th floor, it's floor D. Because D is 13 in hexadecimal. It represents the same value. So you can avoid the mentioning of 13 altogether. It's like, oh, we have floor D. So it goes 1, 2, 3, 4, all the way up to 12, and then you have D, and then you have 14, and go and continue. But you have to remember to put a 0x before the D to mean that it's in hexadecimal instead of decimal. Otherwise, programmers will have a problem with that. D? What is D?
That's the hacker floor.
Hacker floor. That's good. That is good. I like that. All right, so we have line numbers only because we don't have any global variables and no conditions to evaluate. So the first thing is, we know where we should start with line 4, right? Because line 4 is the first line outside of the definition of a subroutine. But we have a problem now, okay? Because before, when we have invoke, we just say return line number so that when we come back, we will continue execution at that specific line. But it doesn't work out that well in this case, because if I use return line number here, I will have to use a particular line. I'm going to get into a problem whether I'm going back to line 4 or post. The problem with continuing at post is I'm not going to print anything. I will go to the subroutine lucky number, do whatever line 13 is supposed to return, and then I will continue execution at post, completely forgetting that I'm supposed to print that number out to the screen or printer or whatever. If I change this post to 4, I have another problem. Because when I return to line 4, I'm just going to do the entire line all over again. Okay, which will turn this into an infinite behavior because I cannot get out of it. So I cannot do a return line number anymore. I cannot just use a line number to tell me how to continue execution after a subroutine is done. What I need now is something a little bit more specific. So what I'm going to do is I'll change the notation. Instead of return line number, I'll just say return information. Okay, this is information that can help me decide what else I need to do when the subroutine is done. Okay, so this is a fundamental change of how we remember, how to continue execution when the subroutine is done. Are we doing okay so far? Yes.
Are we always going to be using return info for this point forward, or will we still be?
It is up to you to decide. Return info gives you more information. In other words, when we traditionally use return line number, you can put in the entire line of the following line, or you can just use return line number. Okay? But when the subroutine is returning a value, you should always use return info when you're invoking. Okay? All right. So in this case, return info has to has to indicate that I have unfinished business on line 4. Because the invocation is only going to take care of invoke lucky number, it doesn't take care of the printing part. So in this case, what I have left to do is the printing. But how do I know what value to print? Well, I don't know yet because it is to be determined by the subroutine. So the value that is to be determined by the subroutine is now represented by a question mark. In other words, the question mark is a placeholder for the value to be determined by the subroutine, a return in the subroutine. Are we doing okay so far? Now, this is all kind of new concept because we have not encountered anything like this before, and some people will look at this and go like, but why do we have to go through all this trouble, and change the way we do things? There are good reasons that we are doing it. Okay, so the return line number becomes a return info. And it still tells us how to continue execution. It just tells us a little bit more than before. Instead of just which line, it is now telling us what else on that line we have to do. So now we continue execution inside the subroutine starting on line 2. This is the only line inside the subroutine that is useful. It has a return statement. A return statement inside the subroutine, its only job is to say, oh, you know what, that placeholder that we had earlier, now we can replace it with a concrete actual value. That's what a return statement is going to do. So in this case, the return statement, or return 13, is going to change the question mark to 13, the value that we are actually returning. So we go here, we copy and paste the return info, just copy the entire line, and then change the question mark to the value that we are returning, and that's all it is supposed to do. Okay, a return statement is only going to change the question mark to the value that we are supposed to return and not do any other type of interpretation or evaluation. It's just a replacement operation. Are we doing okay so far with the effect of a return statement? Are we good? Kind of? Okay. And then we go to line 3. Line 3 is the end of a subroutine. It's going to do exactly the same thing as what a return or an end of a subroutine always does. First, it has to look for the the rightmost return line number or the return info column. In this case, it's column B. It tells us that we are supposed to go back to line 4, so we say line 4 here, and then we have no use of this column anymore. We just mark it as not used anymore. Now, the most important part here that I cannot easily represent, you can choose how you want to do it. Okay, there's one way to represent it, but it will kind of make the program or the trace a lot longer. Is instead of just going back to line 4, you can actually just copy and paste the entire return info like this. So by the time we get back to line 4, you know exactly what else we are doing on line 4. That's up to you. Okay, that part is entirely up to you, because when we have a longer line, that means line number will also be, get a lot longer. Are we doing okay so far with this? Okay. So when we come back to line 4, on row 6 of the trace, do we have to do anything else? There's nothing else to do. We can just go ahead and print the number. So in this case, I guess I do still need a comments column, because I need that to indicate we are printing the value, 13. And after line 4 is completely done this time, we get to post, and we are done entirely. Are there any questions about this sample program, about the concept of returning?
So you're saying that on line 6, you don't have to necessarily declare the line number print 13?
Yeah, if you know how to look it up, you can just say line 4, but you have to keep in mind what else on line 4 you do. Okay. Yep.
What would happen if there's another return statement inside this? After return?
That's a good question. That's a very good question. The question was, what if I have multiple returns inside the subroutine? It depends on the programming language. In some programming language, like Visual Basic, if you have, they don't have the return statement, but they have something that is equivalent to a return statement. Okay. But if you have multiple of that, the last one is the effective one. In other words, you keep changing the placeholder, the value of the placeholder. So whatever is the last one is going to be the one that specifies the actual value. In a programming language like C, a return statement is actually automatically and defines sub as well. So by the time you get to a return statement, not only is it going to fill in the question mark, it will also go all the way down to the end define sub and actually get out of the subroutine. That's the behavior of a C program or C++. Okay, any questions about that? That was a very good question. Does everybody understand the answer to that question? Yep.
I mean, in actual programming, would you actually have 2 return statements, or would you just have a return statement that returns multiple values?
That's a programming style problem. Okay, it's a programming style issue. Some people like to do that. They have multiple return statements. Inside conditional statements. And from my perspective, it's actually a very bad practice to have multiple return statements. So I would use only one return statement, unless the program really lends itself to multiple return statements. Okay. Any other questions? Very good questions. No other questions? All right. So I'll save this program first, and then we'll move on to a slightly more complicated example. So I'll just call this one simple return, because it is as simple as it gets. All right.
So return's kind of like copied something, waiting for it to.
Return is kind of like filling in a placeholder. When you invoke something that can return a value, you are leaving a placeholder and say, okay, this is to be determined by the subroutine that we're invoking. Okay. All right, so let's go ahead and do something that is, that seems to be fairly simple to do. So we'll define sub, add, and it has byval x, byval y, and it will return x plus y. This is actually a part of your homework assignment. So I'm doing a little bit of your homework assignment here. We'll say print, and in this case, invoke. This time, let's do it a little bit differently. I have a global variable I, and I gets the result of invoking add with 4 going to parameter x, and 10 going to parameter y, and that's the program. Technically speaking, this program has no new concepts introduced, but it is combining the concept that we just talked about with the concept that we already know, which is parameters. So we'll go ahead and take a look at the trace of this program. We have line number, and that's it. All right. The first line that we have to execute, the only line that is outside.
Global variable I then?
Yeah, oh, you're right. So I needs its own column, starts with something unknown. That's our precondition. Very good. So now we can start the execution on line 6. Line 6 is going to invoke the subroutine, but just like last time, we cannot use a return line number because the subroutine that we're invoking has a return statement, and there are other things that we have to do when we come back to line 6. So that's a clue that we have to use return info instead. When you use return info, you have to not only indicate the line that you're returning to, but also what is left on that line to do, and also a placeholder representing the invocation itself. Are we doing okay so far with the notations? Okay. And then we can continue execution in the subroutine, and the only line that we have to trace is line 4 and line 5 in the subroutine. So we'll start with line 4. Line 4 says we want to return x plus y. That means we have, oops, I forgot one thing. I forgot to set up the parameters. So x is a parameter, it has its own column, y has its own column. X is specified by the invoke statement, and so is y. One has a value of 4, the other one has a value of 10. I forgot about the parameters. Okay, so this, now it makes sense. So by the time we get to line 4, we want to compute the sum of x and y. X is 4, y is 10, the sum is 14. What am I going to do with 14? I replace the question mark with 14 in this case. So I copy and paste the entire thing and just change the question mark to the value that I'm returning, which is 14. And I'm done. I'm not changing I here. I'm only filling in the blank. That is very important. Okay? A return statement, its only job is to change the question mark to a specific value. And as tempted as you want to do and say, oh, I want to change the value of I or column B to 14, don't do it here because it is not time yet to do it.
Are we supposed to do anything with line 2 and 3?
Sorry?
Are we supposed to do anything with line 2 and 3?
No, line 2 and line 3 are declarations. They're only declaring that x and y are parameters, so they don't really have anything to do. Okay. So now we continue execution with line 5, which is the end of the subroutine. It has two things to do. One is to look up the rightmost return info cell or return line number. This is it is column C in this case. This is the return info cell, and I'm going to change the standard a little bit and just copy and paste the entire thing so it is clear what else we have to do when we go back to line 6. And then after we make use of that, of that information, we have no use of column C, D, and E anymore. So we just deallocate all 3 columns, just like before we talk about return values. Now we are back onto line 6. But line 6 is not like line 6 originally. Line 6 is now, I gets 14. We know how to do that. We execute that statement at this point. I gets a value of 14. And there are no additional statements. We get to post, and we're done. Are we doing okay so far with this particular sample program? Okay, very good. So we'll go ahead and save this program into today's folder. And this is still kind of simple, so we'll just call it assign return because we are using the return value to finish an assignment statement. So save it. Next, we'll take a look at something a little bit more challenging. I did not really have to delete everything because I'm going to use add again. I val x, I val y. return x plus y, and define sub. And this time I want to do a multiplication too. Again, bival x, bival y, and it returns x times y. And then what I want to do this time is to do it this way. This time I want to have things nested. In other words, I want to use one invoke to supply the value to a parameter for another invoke. So it's kind of nested. So we'll go ahead and print, we'll make the multiplication as the outer operation. And the first parameter of the multiplication is the result of invoking add. This time we'll just use 2 to specify x, 3 to specify y. And the result of this invocation will specify parameter x of mult, and we'll just make a constant for the other one, that's say 6 to specify y. And this is the program that we will trace this time. Fix the indentations first. All right. All right, so let's go ahead and start tracing the program. All right, so it's a little bit hard because line 11 is kind of long. We'll have one column for comments, but we don't need it until much later. So we'll go ahead and scroll past it so we can focus on the rest of the program. We have line number. We don't have any global variables this time, so pre has nothing to say. We start execution on line 11. And what should I do? We have 2 invokes here. Which one should I take care of first? The innermost one. Very good. Okay, it's just like evaluating nested parentheses with your normal infix notation. You start with the innermost parentheses and then you work your way out. So in this case, we have to take care of the add first. So the return info is still doing the same job as last time. It is still telling us to go back to line 11. It's telling us what else we have to do by the time we get back onto line 11. When we get back to line 11, the print part has not been done yet. The mult part, or the multiplication, has not been done yet. The only thing that is done is we will have a value to specify parameter x of mult, and 6 to specify parameter y is already a given. So this is the rest, quote unquote, the rest of the line on line 11 by the time we get back onto line 11. Are there any questions about this step? Because we have 2 invokes on line 11, you only replace the quote unquote active invocation with a question mark. The other one, you just leave it intact, just like the way it is. Are we doing okay so far? Yeah, go ahead.
So wait, so we leave the part where the invoke add is the question mark, and then we write the rest of the line out.
Exactly.
Okay.
We only replace the quote unquote active invoke, the one that we are taking care of. We only replace that one with a question mark, but everything else we just copy and paste. So in fact, the other way to do this is to copy and paste the entire line 11 and only replace the one invoke that we are dealing with a question mark and leave everything the way it is. All right, so now we can continue execution in the subroutine add, which is starting on line 4. Oh, I need parameters. I keep forgetting the parameters. Okay, parameter x, parameter y, and these 2 are already specified. We have 2 to go to x and 3 to go to y. And let's see if I can reformat these a little bit so it's easier to read. Yes, it's still okay. Okay, so I don't need that much space at this point. We can just continue on to line 4. Line 4 is return x plus y. And just like before, the return statement is going to replace the question mark in return info, the rightmost return info, with the value or the value of the expression that we are returning. The expression is x plus y, x is 2, y is 3. So x plus y is 5. We are returning 5. So that means we copy and paste return info, and only change the question mark itself to 5, and that's all we have to do with the return statement on line 4. After line 4, we have to go to line 5. Line 5 has 2 things to do. One is to look up the rightmost return info or return line number. We have a return info in this case. Then we have to copy and paste this so that we know what we have to do when we get back onto line 11. And then the second thing it has to do is to deallocate all the columns that were allocated earlier. So we go back to all these columns and change them to strike through to remember that these columns are once again available. Are we doing okay so far with this program? So once we are done with line 5, we get back onto line 11. But when we get back onto line 11 on row 7 of the trace, it's simpler. Now we can actually take care of the multiplications. So this is the place where it gets a little bit it gets cumbersome, but not complicated, because we are going to use up more space basically, and I'm going to shrink the screen a little bit to fit everything, because now we are taking care of the invoke mode here. So when we set up return info again, it will be remembering that we have to go back to line 11 to take care of the print this time. So print will still have to be done, but the invoke is going to be replaced by a question mark. And once again, we have to set up parameter x and parameter y. But it's easy because parameter x is 5, which is the result of invoking add. And parameter y is 6. And now we can continue execution in the multiplication subroutine. The multiplication subroutine really has nothing exciting going on. It's just going to return x times y. X has a value of 5, y has a value of 6. We are returning 30. When you say return 30, all you're doing is to copy and paste the return info cell, change the question mark to the value that we are returning, which is 30 in this case, and you're done with the return statement. And that's on line 9. After line 9, we go to line 10. Line 10 has 2 things to do. The first thing is to look up the rightmost return info or return line number, and it is column C again. Column C has this as our return info, so we copy and paste it here so that we know we have to go back to line 11, and it looks like this by the time we get back to it. And then we have no use of these 3 columns anymore. We copy and paste them and mark them as deallocated. And now we can go back onto line 11. When we get back to line 11, it is simply print 30 this time because we have just resolved both invocations. So now we can go ahead and just execute or finish the print part to print 30 to the output. And there's nothing else to do, so we get to post. Are there any questions about this trace? We have an invocation inside another invocation. Basically, the first invocation, or the innermost invocation, supplies a value to specify the value of a parameter of the outer invocation. But it's no different. Okay, this program is really just doing the same thing as this. Print 2 plus 3, the whole thing times 5. That's all it's doing. Oops, times 6, sorry. That's all it's doing. And that's why we had that little discussion of infix, prefix, and suffix. Because if I write this using the prefix notation, then it will become multiply plus 2, 3, and then 6. Does that look familiar to you in the prefix notation? It's just a way simplified version of line 11 in the pseudocode. It's just way simplified because we don't have to name the parameters and also the arrows and invoke. And syntax-wise, it's a lot cleaner. But in terms of the nesting and the construct, it's identical. Are we starting to see the value of being able to return a value? Because we can utilize the result of a calculation right away without having to store it first into something else using a by-ref parameter. Is that okay? All right. Well, this is good. Let's work with something that is more confusing. Okay, so we'll confusing, yes. Well, confusing means, it's a good test to see whether you actually understand the mechanism itself, because if you understand the mechanism itself, the so-called confusing examples should not be confusing, because you're just kind of mechanically and blindly following the same procedures again and again. So this one I'll call that nested invoke, because we have an invocation inside another invocation. So we'll close this, and close this one, and then we'll go ahead and start with a new program. We'll start with something simple first without recursion, and then we'll do something else that has recursion and makes it a little bit more complicated. So we'll define sub, this time I'll just say, a number, okay? And it simply returns a particular number. We'll call that, I don't know, 42, okay? You guys know why I picked 42. Yep. And then I'll define another subroutine here. Okay, dolphin. Dolphin returns a number. Okay, since we are already, on the track, might as well. And people who do not know what I'm talking about, hey, it's just the name of a subroutine. It says. All right. So now what we want to do is to, wait. Made a mistake here. I cannot just say a number, because I have to say invoke a number, because a number is not a variable, it is a subroutine. Yep.
So we can call subroutine whatever we want.
As long as the invoke statement is consistent with the name of the subroutine, yes.
Beware the leopard. Beware the leopard. Beware the leopard.
Oh.
Just making another.
Yep. All right. So the outermost part here is, let's see, fish. Yes. Invoke. Right. So here. All right. There we go. It should be the other way around. I think we should feed the fish to the dolphin, but so it's okay.
Gotta add a towel in there somewhere.
And the whale. I like the whale. The blue whale, free falling, thinking about all the different things. All right, so we don't have any prints, so we can bypass the comments column altogether and start with line number. There's nothing to say. Oh, we do have something to say, because we have a global variable called fish, and it starts with unknown. Okay, so that's the easy part. And we start on line 7. By this time, we should know what to do with line 7. It needs a return info, because we are going back to line 7 again to finish some unfinished business. When we get back, line 7 only has the assignment portion left. So fish equals, fish gets, whatever the subroutine dolphin is returning. And dolphin does not have any parameters or local variables, so there are no other columns that we have to allocate. We go into dolphin, and we go to line 5. Line 5 is kind of tricky even now, because it is a return statement, but I cannot do the return part until I invoke a number. So that means, that is funny. So on line 5, the first thing I have to take care of is the invocation. Okay. Now it doesn't matter where the invoke is; it is still the same mechanism. It can be inside, another invoke. It can be inside a return statement. If you have to invoke a subroutine that returns a value, it still goes through the same motion. So in this case, we still have to set up the same thing, which is the return info cell, so that I know what else I have to do on line 5. When we get back onto line 5, we can finish up the return portion, and what we are returning, the question mark, is determined by the invocation of a number in this case. Okay? Instead of saying a number, I should have called it answer. It's okay. It's not nitpicking this time. All right. So when we invoke a number, we continue execution on line 2. Line 2 is simple, right? Line 2 has only one thing to do. It is to replace the question mark of the rightmost return info cell with the actual value that we are returning. We're not dealing with column C here because it's not the rightmost one. The rightmost one is actually column D. So we go to column D, we copy and paste it, and then we change the question mark itself to 42. But we do not return 42. Okay, we do not execute the return 42 here because it's not time yet. We are not on line 5, we are on line 2 at this point. Okay. So after we are done with line 2, we go to line 3. Line 3 has two things to do. One is to indicate where we are supposed to go back to. Okay, so column A is now a little bit bigger. And then the second thing is to deallocate. Oh, I picked the wrong one. Sorry. There we go. There we go. You have to use the rightmost one, not just any one. Okay, so we are supposed to go back to line 5, and line 5 now looks like this. After we make use of column D is no longer useful to us, so we'll go ahead and deallocate it. Now we're back onto line 5. What is line 5 going to do? Return 42. So we execute this return 42 at this point to change this question mark to 42. Now this is the tricky part, okay? It is only now that we change this question mark because we are executing return 42 on line 5. So that means we have to copy and paste this this cell over here, change this question mark to 42, and that will finish line 5. After line 5, we have line 6. Line 6 has two things to do. One is to remember what else we have to do on line 7, and then the second thing is to deallocate column C at this point. Oops. Paste, and then change these right through. So now we are back on line 7. But line 7 is fish gets 42. So now column B is updated to a value of 42. After line 7, there's nothing else to do. We get to post, and we are done. Are there any questions about this one? Because this one has a return that also has an invoke in it. Is that okay? Kind of? If this is okay, we can finish the last revision of the factorial program. It will look very nice and clean, and I will tell you, why I may not like the first version of it, that we'll talk about next. All right, let's go ahead and save this program first. And I'll just call this fish, dolphin, answer. Oops. Okay. Shall we move on? So now we get to, I should not have closed the entire application. There we go. All right, so we have factorial again, but instead of factorial, I call it F because we have enough, junk on the lines. So we just simplify the name of the subroutine. It has one single parameter passed by value, which is n, the number that we want to find a factorial of. And then the rest is really simple this time, because it is just saying, if n is greater than 0, then return n times the invocation of f passing n minus 1 to n. Like that. And else, it is just returning 1. And if n defines sub, we need to fix the indentation. And the outside of the subroutine, let's just say that we want to find the factorial of 3. So, and that's the program that we are going to trace. So this time we do have multiple returns inside the same subroutine, but because one return is in the then branch and the other one is in the else branch, we don't have a problem. We cannot execute both returns at the same time or in the same invocation. So it's okay, it doesn't really get into the problem that we can potentially get into. So we'll go ahead and trace this program. Don't you think this is a cleaner, much cleaner version of factorial compared to all the other versions that we have before? Okay. So we'll go ahead and trace it and see how it works. Because this one actually, there's no new concept in this particular sample program. It's an integration of all the concepts that we have learned so far. We got comments, line number, we don't have global variables. First line is line 9. And line 9 is to set up a return info because we have to invoke subroutine F in order to find out what value we are supposed to print. So we have return info here. We need to go back to line 9 again to finish up the print. The value that we are printing is going to be determined by this particular invocation of F. So after we set up return info, we also have to set up the parameter n, because n is passed by value. So it just has a value of 3 in this case. And then we can continue execution in the subroutine on the first line. In this case, it's line 3. Oops, one column. Line 3 has to evaluate n is greater than 0. Is that true or is that false? True. It's true. Yeah, that's an easy one. Then we go to line 4. Line 4 looks kind of complicated. We have to return n times invoke F again, using n minus 1 to specify n. It looks kind of complicated, but I really can't do the multiplication and I cannot do the return yet because I have to find out what the invoke is going to return first, right? So that means by the time we get to line 4, we have to set up return info again. When we get back onto line 4, we have the return to be determined. The n times part is also to be determined. We have only determined at that point what we are multiplying with n at that point. Okay? So this is very important. The important part is I do not substitute the value of n into the cell E7. Okay? I do not. Okay, let me just make it very clear. I do not use 3 in this place. I just use n. Okay, that is very important. Okay, do not use any substitution unless you're unless you're executing return. All right, we also have to set up the new n. What should the new n be? I think by this time we should kind of know how to set this up. 2. Yep, because it's n minus 2 because the n of n minus 2 is referring to column D, which has a value of 3. 3 minus 1 is 2, so we use 2 to set up the new parameter n. And then we can go into the subroutine again, starting on line 3. Line 3 says n is greater than 0 is true again. We go to line 4. Okay, so we can just kind of copy and paste these 4 cells, except n is now 1. We continue execution on line 3. N is greater than 0 is true one last time. Then we go to line 4 again. And we'll go ahead and split the screen so we can see it a little more. So we copy and paste these 4 cells over here. Change n to 0 this time. And then resize the columns just a little bit. And then we can continue execution on line 3 again. N is greater than 0 is now false because n is 0. So we cannot continue on line 4 anymore. We have to continue with line 6. Line 6 is return 1. That's pretty easy, right? What should we do on line 6? Can you guys describe what I should do on line 6? Find the rightmost return info cell, copy and paste it, change the question mark to the value that we are actually returning. In this case, it's 1, and I'm done with line 6. So we'll go ahead and do exactly that. We locate the rightmost return info cell, which is on column I. This is our return info cell. Copy and paste it. Change the question mark to the value that we are returning. We are on line 6, we are just returning 1, that's it. And we are done with line 6. Okay? We do not evaluate n times 1. We don't know what n is. We just know that the question mark is 1. Then we continue execution outside of the conditional statement. We are getting to line 8. Line 8 has 2 things to do. Look up the rightmost return info cell and copy and paste it to the line number. So now we know we're supposed to go back to line 4, and by the time we get back to line 4, we have to compute n times 1 and use that as a return value. And then the next thing it has to do is to deallocate the columns that we have allocated for this invocation. And that's it. Now we are continuing on line 4. Do we have any questions at this point? Nope. All right. So now we are on line 4. What is line 4 supposed to do? Line 4 is supposed to compute the product n times 1 and return that value. All right. First question. Which n are we talking about? Column H, very good, because that's the rightmost column with the label of n. And so 1 times 1 is 1, so we are effectively returning 1. So what should we do now that we know we are supposed to return a value of 1? Copy and paste which column? Column G, all right, very good. We are returning a value of 1, so we copy and paste column G and replace the question mark with 1, and that's it. But tech, there's another n in there. Do we need to resolve that n and simplify n times 1 to n and do all sorts of stuff? No. The answer is no. Okay? When you execute a return statement, the only thing you have to do is to change the question mark, which is a placeholder, to the value that you're returning. The rest, whatever is the rest of that cell, in this case, cell G17, it doesn't matter. It can be anything. Okay? You're just going to change the question mark to the value that you're returning. So you can say that, but these two look exactly the same. The line that I'm executing is going to look exactly the same as the return info cell that I'm returning. It's okay. Okay? Don't get bothered by that. This is fine. All right. So after line 4, we get out of the conditional statement. We get to line 8. Again, line 8 has 2 things to do. One is to look up what we are supposed to do after this. So it has to look up the return info cell, the rightmost return info cell. The second thing it has to do is to deallocate those 2 columns, the 2 columns that we allocated earlier for this invocation. And then we can continue execution on line 4. Now columns G, H, I, and J are now, they're all deallocated. Oh, I forgot to deallocate it. So let's go ahead and deallocate those 2 columns. So these columns are now gone. We have to scroll our screen a little bit. In fact, we can get rid of the dual screen here. So now we are back onto line 4, and once again we want to compute n times 1. But which n are we talking about now? Column F. Column H is gone. Okay, the rightmost column that has a label n is column F. So column F has a value of 2. 2 times 1 is 2. So when we execute line 4, we are effectively returning 2. When we return 2, what we do is we look up the rightmost return info cell, whatever it is, copy and paste it, change just the question mark to the value that we are returning. What value are we returning again? 2. That's it. Okay? Don't get bothered by the rest of the return info cell. We don't care. Then we move on to line 8 again. 2 things to do. First thing is to remember where we're supposed to go back to. We're supposed to go back to line 4, and line 4 now looks like this. And then the second thing is to deallocate the columns that were allocated for this invocation. And now we are continuing on line 4 again. Line 4 wants to compute n times 2. Which n are we talking about? Column D. And column D has a value of 3. 3 times 2 is 6. So we are effectively returning a value of 6. So return a value means look up the rightmost return info cell, copy and paste it, change the question mark to the value that you're returning. In this case, it is 6. And you're done with the return statement. Get out of the conditional statement, get all the way to the end of the subroutine on line 8. Line 8 has 2 things to do. Look up the rightmost return info cell. It tells us that we have to continue on line 9. Okay, so that's how we remember that we have to continue on line 9. And then we have no use of those 2 columns anymore. Mark these 2 as available at this point. I know it's boring, it's supposed to be. And now we are back onto line 9. Line 9 now has only one simple thing to do, which is to print the value 6. So we just go ahead and print or output 6 to the screen or printer or whatever device you want to output to. And after line 9, there's nothing to do, we get to post. It is supposed to be boring because I'm repeating the very same mechanisms just over and over again. Do we have any questions about this? No questions? Okay. All right. That's good. I mean, that's because we are done with all the concepts related to subroutines. I'm not kidding. We are pretty much done with all the concepts, basic concepts related to subroutines. By the time you get to the next class, cisp360, and also later on in cisp400, there'll be some other tricky things, like you can actually return a reference. Instead of returning a value, you can return a reference to something else. We're not going to deal with it in this class. Okay, so we are not going to do anything that's complicated like that. We're just going to focus on the basic stuff of using a subroutine. Any questions? Yep, go ahead.
Do you know like which the recursion depths in certain languages?
Sorry?
Do you know the recursion depths in certain languages? Like off the
It
top of your
depends
head?
on the stack, what we call the stack. That's a very good question. The question was, do I know the depth or how many times we can do recursion, before the system starts to have problems? Okay, that was the question. And my answer was, it depends on the size of the stack. The stack, we haven't really talked about the stacks, right? Well, the stack is basically the number of columns here. The columns that we are dynamically allocating is collectively called the stack in technical terms. You won't encounter that term until you get to cisp400 or cisp310 in assembly language programming. Then we'll look at these pictures again, but in a different way. Okay? So the way I'm teaching this class is setting you up not only for cisp360, which is the C programming class, but also for cisp310, which is assembly language programming. Okay, so by the time you get to cisp310, when I talk about the stack and how we use the stack to pass parameters and stuff like that, you just have to remember what we go through in this class, and the concepts are exactly the same. All right? Are we doing okay so far with subroutine calling? I'll just go back and look at the homework assignment one last time after I save this, and see if you guys have any questions about the homework assignment, because it really has only about the same stuff as here, except things are arranged a little bit differently. This will be factorial. We are done with factorial. This is the last revision of factorial. So going back to the okay, I know I already have the file opened earlier. It is sub 2. There we go. Okay, I'll just kind of go through this, step by step. I'm not going to tell you what the answer is, but I can at least go through invoke main. Okay, so we go to main here. Main has a local variable I gets a value of 2, and then this is our first invoke statement. It's invoking a subroutine assign. Assign does not return a value, so it's okay to use return line number when you invoke assign. But before you invoke assign, you have to invoke add first, so that you know what is the value of parameter y. So when you invoke add, okay, add is here, it simply returns the sum of the 2 parameters, and you can use that to specify parameter y. And after you have parameter x and parameter y specified, you can then go ahead and invoke assign. Oh, I I made a note. Oh, no, that's fine. Okay. So parameter assign has two parameters. X is passed by reference because we are changing x. Y is passed by value because it is only supplying the value of the right-hand side of an assignment. After line 19, you get to line 20. Line 20 is going to invoke post inc, which stands for post increment. And I'm passing I by reference to x. X is a parameter passed by reference. I'm adding 1 to x, and yet I'm returning x minus 1. And I'm using that value as a return value to change I. So this one is kind of tricky because I gets changed multiple times, and you just kind of have to figure out what is the actual value of I after line 20. Yep.
So with the double arrow ones, is you feed the right side first, and then once you, like with the invoke.
The double-sided arrow is an indication that we are passing by reference,
Right.
which means parameter x is an alias of the column that we use to store local variable I.
Okay.
In other words, by the time we get into the subroutine in post increment, line 3 and line 4, x is really just an alias of the same column that we also label as I. Okay. So this means the order of operation becomes very important. Does the assignment go first on line 20, or do we do the increment first on that line? So you got to make sure that your order is correct, because otherwise the result would not be the same. And post increment, interestingly, is also one of the operators in C and C++. So when you get to CISP360, you will also see this operator. In fact, that's also why C++ is C++, because the post increment operator is plus plus after a variable name. So C++ is basically C but incremented, better, improved. So that's an inside, I guess you can call it an inside reference of why C++ is called C++, because it's one step better than C. But it's a post increment operation, and that's exactly what a post increment operation should do. All right. Are there any questions about this homework assignment? It kind of exercises a lot of the stuff that we talked about today. So going over the sample programs that we kind of went over today would be helpful. But for the most part, the concepts are the same. We only have a few really key concepts. The rest is just not getting confused when we combine the concepts in different ways. Any questions about subroutines and stuff like that? So as I said, we'll talk about the practice exam next Thursday, because I want you guys to do this first, and then we'll talk about the solution of this one. We'll talk about the practice test, practice exam 2, and then 1 week after that, we'll have the actual exam. So that means, we'll do it after Thanksgiving. Okay, just 1 week after Thanksgiving. So the second exam and the final exam will be kind of close, but there will still be enough time in between we can cover some additional material, which is records. Okay. Yep.
Is there going to be an extra credit assignment for the first test?
Yeah, I will make a extra credit homework assignment. Okay. Are there any questions about subroutines? Because that's kind of, it's really, really important. All right. If there are no questions, we are not ending the class just yet. I know most of you are thinking, well, can we go?
Did you pass the sign-in sheet last time?
Hmm?
Did you pass the sign-in sheet last time?
You mean roll sheet?
Yeah.
Oh, I should pass it around. This would be a good time. So people who are just waiting to get out have to go, oh man, I have to stay and put my name on that roll sheet first. All right. So as you guys are scrambling and get all your notepad and whatnot back out again, I'll go ahead and finish up this chapter. So once again, you might want to read the updated subroutine notes first, because it is more up to date. It has the same notation that I use in class these days. But the other part is also just as important. Classifying names in a subroutine is also very important. In other words, ideally speaking, we like to do everything in a top-down fashion. What do I mean by top-down fashion? Well, you start with a subroutine that includes all invocation of all the other subroutines, and each subroutine should be relatively small and easy to maintain, right? That's structured, it is top down, and everything is good. Except in real world, we don't do it that way. So many times, you will actually end up writing a subroutine that is too long. By the time you're done with a subroutine, because you keep adding more and more logic, more loops, conditional statements and whatnot, the subroutine will end up to be a little bit longer than you think it should be, 150 lines or so, and you think, well, I'm kind of have to scroll the screen to see the entire thing. It's a little bit too long. So the question now is, how do you turn something that is not in a subroutine into something that will invoke subroutines? That's the question. So we'll go ahead and take a look at this note here. And it has one example, and I have to kind of shrink the screen a little bit in order to show you the entire program. So the program is not really that hard, okay? I just want to get two numbers from an end user. The first number has to be between 1 and 100. The second number has to be from the first number to 100. So it specifies a range. And then I just want to print all the numbers within that range, and that's the end of the program. All right? So when you read this program, what is the first thing that you notice?
Comments.
Well, the lack of comments. Line 1 and line 2 comments. Yep. But what is the second thing? How about the structure of the program? What do you notice in this program? Do you notice certain section of the program seem to be very similar? Has about the same thing, not exactly the same, but very similar in terms of the structure.
Yeah, you got 2 loops.
Sorry?
You got 2 loops.
2 loops, okay. And the 2 loops are very similar to each other. Okay, so let me just take a look at this program. I will highlight which part we are talking about. If you look at line 5 to line 11, it represents one loop. What do we do in the loop? We print a prompt, we read a number, we do a range check, and see if we have to print an error message. And then we have an until to say that until both of these conditions are true, we can get out of the loop. You look at the second loop from line 12 to line 18, it has about the same stuff in it, right? It has a print, which is to prompt the end user to input a number. The range is different because in the first loop, we have between 1 and 100. In the second loop, we have between L, which is a variable, and 100. But otherwise, they look awfully similar. And then we have, after that, we have read L in the first loop to read the lower bound. In the second loop, we have read H, which is the upper bound of the values that we want to print. That's kind of similar, different variables, but similar. And then we have a conditional statement. In the first loop, we are checking to make sure, we are seeing whether L is lower than 1 or greater than 100, because those two cases are error cases, and we want to print an error message. In the second loop, we have about the same thing, except the limits are different, okay? Because we want the second number to be at least as big as the first number. So if the second number is lower than the first number, it is a condition that we have to warn the user about. If H is greater than 100, it is also exceeding the boundary, and we have to generate an error message too. So it has a lot of similarities. The actual useful part of the program is really here, from line 19 to line 24, is the actual useful part of the program, which is to print out all the numbers from L to H, all the integers from L to H inclusively. All right. So the entire program is really just, trying to input two numbers, both between 1 to 100. The first one has to be less than or equal to the second number, and then we print all the numbers within that range. That's all the program is supposed to do. But when you read the code, it doesn't really tell you that. Okay? Now, if I go to, let me just kind of show you the end result of after everything is done. That's not it. I should have finished it. Oh, there we go. Okay, so when we have a cleaner version of it, this is what it looks like after I cleaned it up with subroutines. So after I clean it up, we have local variables L and H for lower bound and the upper bound. And then instead of having those two big loops in the program to kind of interrupt the reading of the flow of the program, I am invoking a subroutine. I'm invoking the same subroutine. The first one will specify 1 as the lower bound beginning, 100 as the upper bound, and whatever we read into from into N, we want to store it into L, which is our local variable. The second one is invoking the same subroutine, except the boundaries have changed. I'm using the first number, L, as the lower bound of the second number. 100 is still the upper bound, and I want to store the new number into local variable H. So I'm reading two numbers. The first one is L, the second one is H, and then I can copy and paste the same logic here. Is that easy to read? Okay. It's a little bit easier because it doesn't have the two big blocks of code that have a lot of similarities. Okay. And then the second part that's really nice about this is I'm defining a single subroutine called readNum to handle the logic of reading a number. So in this case, you can see that the two loops that I showed a little bit earlier is actually here, except there's a small difference. I have just parameterized a lot of that code. If you read this code here, you can see that the beginning and the end are no longer literal constants. They're not like 1 or 100. They are now passed by value. They're passed by value parameters. Okay. Well, that's nice because now I can reuse the same logic no matter what the ranges are, because it's just a parameter that I have to pass. The number that I'm reading into is passed by reference n, so I can just say reading into n, and then I can use n for the comparison, and the error message or the triggering of the error message is just comparing n to b and e. And even the error message itself is only repeating b and e, which are parameters passed to the subroutine. The boundary to get out, the condition to get out of the loop is also based on b, n, and e, which are all parameters. So in this case, my program or the logic of reading in a number with bound checking is now abstracted to a subroutine. Every time I need to read a number between a certain range, I can just call this subroutine. Okay, so the program gets simplified on one hand, and also on the other hand, it is also easier to read. So the question now is, how do we go from the original version of the program to this particular program where we have a subroutine to not only help shrink the size of the program, but also to make it easier to read? That's the question. How do we go from the first messy, long program to the cleaner and better structured program? So that's exactly what this entire module is about. Is how do you step by step go from the tedious version and then just work on it step by step to the clean version. We are running out of time today, so I cannot finish it, but go ahead and read it first, and then we can talk about it on next Tuesday. Have a nice weekend. It's going to be a long weekend if you have classes on Monday.